this distance, this short distance from this point to this line? Well, you can kind of see that it's probably going to come right in here. It's going to be somewhere in here at -2, -3, somewhere in here. But we're not sure what, and coordinate planes aren't always exactly, you can't accurately do it with a visual. We need to use algebra. So here are the steps we're going to use, okay? Write these down in your notebook, and then we're going to go through them. So just pause the video and write these down. We're going to find the equation of the line S, then find the equation of a line perpendicular to S, solve the system to find that point, and then just use that point and point V to see how long that line is. So pause and write those down. Glad you're back. Now let's find the equation of line S. We know S has line points 0, 0 and -5, 5. And then we want to go through the point V, which is 1, 5. So step 1, we need a slope. 5 minus 0, y minus y over x minus x. We end up with 5 over -5 equals -1. That's the slope of line S. We have a point. We can use either point to write an equation. I use the ones with zeros and ones if I can, easier. So y minus y sub 1, I'm going to use 0, equals the slope times x minus x sub 1. And that's going to simplify to y equals -x. There's the equation of line S. Easy to do. Step 2, we want the equation of a line perpendicular to S through point 1, 5. So we know our point. It's going to be 1, 5. We know our slope because we know the slope of line S, and we take the opposite reciprocal. So the perpendicular slope is going to be a positive 1. So now we'll write this equation. Y minus 5, remember it's the y coordinate, think of this as x sub 1, y sub 1, equals the slope times x minus x sub 1. Simplify that to slope-intercept form. Add 5. And this is a line perpendicular to S through 1, 5. Now, if I found the intersection of these two lines, I would know that point went a little too far for some reason.
It's still going forward.
Sorry guys, my first day with my new PowerPoint. I would know this point that was coming down here perpendicular to here. If I knew this point, I can use the distance formula. So that's what I'm going for. So I'm going to use substitution. Note that both of these equations equal y. So I can set this, because that equals y, equal to x plus 4, because that equals y. And I can say -x equals x plus 4. A little algebra, take away x from both sides, and I have -2x equals 4. Divide by -2, and I've got x equals -2. So now I know the x coordinate of that point. I can put y equals negative, and I'll put it in my x coordinate to get 2, or I could use this equation, y equals -2 plus 4 equals 2, to get the y coordinate. So either way, my point of intersection is -2, 2. Now we are almost there. The last step is to just find the distance, the length of that segment. So I've got a point right here. That's one end of the perpendicular segment. And I've got another point, and I'll use my distance formula. Remember, x minus x quantity squared plus y minus y quantity squared. So I'll put in 1 minus -2 squared, and I'll put in 5 minus 2 squared. And I will get, remember, minus a negative is plus, so I've got 3 squared, which is 9. Here I've got 5 minus 2 is 3 squared, which is 9. So I have the square root of 18, which is equal to, well, we can leave it as an exact answer as the square root of 18. We could also call that 9 times 2, square root of 9 is 3, 3 square root of 2. So either one of those answers would give you a nice exact distance from the point to the line. So that's the first big process. Now similar to that is to find the distance between 2 parallel lines. And realize that, and when you think about theorems, if 2 lines are equidistant from a third line and they're parallel, then all 3 of those lines are parallel. So let's look at our distance between the parallel lines. So now again, we just want to find this distance, and it's got to be perpendicular to both of these lines. Now the easiest way to do that, well, if you're drawing, you can kind of see, if you laid a paper up here, it'd be this distance here. And it's going to be the same all up and down the line. So what's nice is to find a point that's not a fraction, get a y-intercept here. And let's just find like this distance right here. So again, we have steps for that. And our steps, first off, it's always good to graph the lines. And just so you see what you're doing. And draw that perpendicular line through one of the intercepts so you know what's going on. And then please write down these steps. Notice they're very similar to what we just did. We're going to find our slopes, and we're given equations here, so that'll be easier. And then we're going to find our perpendicular line and solve it just like what we did earlier. New markers, kind of messy. So the first thing we do, we look slopes of parallel lines, think y equals mx plus b, so m is the slope. So if you think about our steps, we know the parallel lines, the slope is 2, because it's the number being multiplied to x. Slope of any line perpendicular to that, perpendicular line, is going to have a slope, think the opposite reciprocal. So instead of 2 over 1, which is what we have there, we're going to have a negative 1 over 2. That's the slope of the perpendicular line. And then, like I said, we want to take that perpendicular through this line and then find out where it intersects this line. So I see that the y-intercept of this line is 3. So I'm going to write my y-intercept. I have another point that's 0, 3 from line A. That's my y-intercept, 3. Now to find the equation of a line perpendicular to A, through this point, I'm going to use my perpendicular slope, my point, 0, 3, and I'll write the equation. Y minus y sub 1 equals the slope times x minus x sub 1. Y minus 3 equals negative 1/2 x. Add 3 to both sides, and we get y equals, let's do it this way. Add 3 to both sides, that's going to make a 0 here. Y equals negative 1/2 x plus 3. This is perpendicular to the parallel lines. So now if I took this, and I could solve a system with this perpendicular line, and well, we've got to use this one now because we used this to get that, we use the point from this one, so now we have to use this one. So we're going to use y equals 2x minus 1. So my system is y equals 2x minus 1, and y equals negative 1/2 x plus 3. Notice again, they both equal y, so I can set this equal to this. 2x minus 1 equals negative 1/2 x plus 3. solve the system, get all my x values on one side, I'll add 1/2 to 2. 2 is the same as 4/2, so I'm going to add 1/2 and I'm going to have, I'll go plus 1/2 x. This will be a 0, and on this side I have 5/2 x, minus 1 equals 3. Add 1, 5/2 x equals 4. And then remember, when you've got a fraction, multiply by the reciprocal. And a number times its reciprocal equals 1. So I have 1x here, and I have 4 times 2 is 8/5. So 8/5 is where the x-coordinate, where my line crosses, my perpendicular line crosses y equals 2x minus 1. Now to find my y value, I can plug it into either one of these, substitute it in here. So 2 times 8/5 minus 1 equals 16/5. Put that over 1. And 1 is the same as 5/5. So 16 minus 5 is 11/5. That would be my y coordinate. If you wanted to do it in the other one, negative 1/2 times 8/5 plus 3, I can do the same thing. I'll do some goes into is 8 divided by 2 is 4. So I have negative 4/5 here. If I do this as fifths, I have 15/5, and we still get 11/5. So you notice, use either equation, works fine. So now I have a point that is x is 8/5 and y is 11/5. And I'm going to use this point, that's one point of intersection, and this point. So this is where my perpendicular intersected this line, and this is where my perpendicular intersected this line, or excuse me, the line y equals 2x plus 3. That's where that came from. And now we want to go the distance between those 2 points. So we're going to do our distance formula here, the square root of, and I have 8/5 minus 0 squared plus 11/5 minus 3 squared. And once you get here, if you've got all this going on, just put it all into your calculator. And let me show you how that looks. Put that up there. Okay, can we go up here? So now I'm going to take the square root. I'm going to put that right in there. And notice it comes with a parenthesis. So I need another parenthesis for my first group. 8 divided by 5 minus 0. Close that parenthesis and square it. Plus, close my parenthesis again and do my second one. 11 divided by 5 minus 3. And square that. And then put another parenthesis in so that I have the parenthesis saying all of this is being square rooted. So you've got 2 sets. I don't have to worry about putting parentheses around my fraction because division comes before subtraction in the order of operations. Then I hit enter, and it's going to be, you can tell if I try to change that to a fraction, it's not going to work. So anytime you've got these fractions like this, you're just going to have to do it like this and just listen to the rounding. So about 1.79, since this is more than 5, would be your distance. Approximately equal to 1.79. So when you get those fractions, that's what you're going to do with those. So steps, check your find the slope of your lines, get a slope of a perpendicular line, find the first equation, get a y-intercept, write the equation of your perpendicular. Then use the second equation and the equation of your perpendicular to get the intersection of the second line of the perpendicular. And then use your distance formula. So let's see if you can do it. Pause the video, follow these steps, see what you come up with. And I'm hoping you came to 2.85. We will be doing this in class, so save your work on this so you can share it with your classmates. And that would be the end of what we're doing with this. So understand finding a point between the distance between a point and a line is a perpendicular. and know the steps to finding the distance from a point to a line and between two parallel lines. And we'll see you in class.